And what is good, daily space weather video viewers? Welcome to the video. We're looking at the sun here in 193 angstroms to see a large coronal hole already providing some coronal hole wind, it looks like. Here's the closest star in 193 angstroms. One of the UV, the ultraviolet electromagnetic radiation emissive states of iron, folks. We've got actually three sunspot groups here. Here's 2814, here's 2815, and here's 2816, which is quite large. Close-ups of that coming toward the end of the video. Here's another view of the local yellow dwarf. This is actually three wavelengths. 335 angstroms, 193 angstroms, and 94 angstroms. All the major magnetic organization happening in the southern hemisphere. At this point, there is some filament activity going on as well, raising the possibility for coronal mass ejections. Likelihood of solar flares goes up as well with the rising of sunspot 2816. Here's a close-up of the southern hemisphere. This is 94 angstroms. Great view of that. Southern hemisphere, the main magnetically organized region of the sun. Here's a diagram of the solar system. There's where things will be in a week. Here's a star chart for all you stargazers. I use in-the-sky.org. I face mine to the south. I'm currently facing to the south. Indeed, my sofa faces the south as well. This yellow line is the ecliptic, the line the sun will take across the sky. If you're up before dawn, you may see Saturn and Jupiter rising ahead of the sun. The 2800 megahertz, 2800 megahertz, or 10.7 centimeter radio flux, only at 72 solar flux units. Here is the 1 year chart of that. It's this black line up here. And you can see how proportional that is to the sunspot number. And we are forecasting some geomagnetic storms here. NOAA's forecast shows a KP of 5 expected first thing tomorrow morning on April 17th. So we're expecting a minor geomagnetic storm. It seems a little bit early for that to me, but we've already seen a little bit of geomagnetic unrest from the leading coronal hole, the one ahead of sunspot 2814. So don't be surprised to see this go on for a little longer than expected, would be my guess. Before we go on, I'd like to remind our viewers not to pole vault the caldera, a public service message from smAsho.com. Our patrons are well aware of the fact they should not be pole vaulting the caldera, so thanks to our patrons at patreon.com/smAshomash. If you'd like the earliest alerts, if you'd like to know before anybody else on Earth when coronal mass ejections are happening, consider becoming a patron. Again, the URL is patreon.com/smAshomash. And thanks again to our patrons, the true source of funding for the content. Were you aware that there's a correlation in Taiwan between groundwater levels and earthquakes? Yes. Yes, indeed, folks. So the graph you're looking at here is the red line seismicity, the blue line water levels, groundwater levels. When we see low levels of groundwater, we see more large magnitude earthquakes at Taiwan. When the groundwater is at higher levels, we see less large earthquakes at Taiwan. Perhaps an indication into the physics behind earthquakes. What's the relationship? That article's on phys.org in the Earth section. Next, looking at the earthquakes over the past 24 hours, no major quakes. Although at least one deep quake, such as this 4.2 at Fiji at over 600 kilometers depth there. And we'll just scroll up the list here. Again, no major quakes over the past 24. Only one deep quake on the list so far. So pretty calm as far as quakes go. A 5.4 and a 5.1 and another 5.4 are on the list. A deep quake near Japan also occurred. Continuing on to volcanoes, we see smAsho in the Aleutian Island chain has been erupting. Let's check the whole list. Sinabung, located at Sumatra, Indonesia, exploding. A discrete volcanic ash emission, discrete enough to produce a 12,000-foot plume of ash. Luatolo, 6,000-foot ash plume there, so that was not on the list yesterday. Luatolo now exploding in the Lesser Sunda Islands. smAsho has had the volcanic alert level raised to warning, aviator code red. Continuous ash emissions and a 20,000-foot plume of ash are the features there in the Aleutian Island chain. Popocatépetl, exploding in central Mexico, 19,000-foot ash plume. Pacaya and Fuego, both in Guatemala, producing 11,000 and 14,000-foot ash plumes respectively as they both explode. Revenador in Ecuador exploding, 14,000-foot ash plume. Sabancaya in Peru exploding, 25,000-foot ash plume. Soufriere in the West Indies, exploding 8,000-foot ash plume there. And Piton de la Fournaise on the Isle of Réunion. A new fissure vent opened there. So it's a bit of a volcanic uptick, folks. This data from volcanodiscovery.com on their Volcanoes Today page. Looking back at the data from the GOES-16, we don't see any major solar flares over the past 24, a couple in the B class range. In fact, part of the background on the GOES-16 long-wave X-ray radiation there, getting close to a background level of B-class X-ray output, folks. So a little bit of an uptick here in solar activity. Surprisingly low radio flux, despite 3 sunspot groups in the southern hemisphere. No proton strikes here. Here's the GOES proton flux over the past 3 days. We show this daily to show how flatlined it is. We only see spikes in this typically when we see coronal mass ejection strikes. The GOES magnetometer is looking spiky here over the past few hours. As we forecasted yesterday, you can see these spiky regions. That is typical of the arrival of a coronal hole wind stream. So the high-speed wind from a coronal hole represents a long sheet of plasma at high speeds in between the Earth and Sun, and that affects the GOES magnetometer readings. There's 3 days of GOES magnetometer, also measured by the GOES-16, the most important satellite thanks to the GOES-16. The satellite showing lots of data. Next, looking at the heliospheric current sheet, you can see how solidly the Earth is in a south pole current sheet here. On this top view ecliptic plane field plot, again, likelihood of coronal mass ejections has gone up a bit here as we've got sunspots, one major, one especially 2816, quite large. All 3 sunspot groups are beta class, and we do have some filaments in between Sun and Earth, as well as the coronal hole wind stream just about to arrive. Here's another view here. It's the line of sight ecliptic plane field plot. It shows you essentially a 3-dimensional line of sight view of the same thing. That blue line there is a reference to the B field. When you see it so far north like that, that's an indication that the Earth is in a south pole current sheet, as we just cited. And here's a line of sight coronal hole plot, and you can see this large coronal hole stretching up toward the equator there, associated with the south pole in red. It also shows you the sun's B field in blue. And we do see some signs of evolution of solar cycle 25. Were you aware that we'll be explaining the solar polar field reversal cycle and the sunspot cycles as a result? It's happening. I believe I've discovered the mechanism behind it. We'll be writing a paper on it. More on that later. Here are the detected sunspot groups and detected filaments. These are largely artifacts over here. There is not a giant filament stretching all the way from pole to pole on the eastern limb. That's some sort of an artifact there. Not exactly sure what's causing that. Perhaps limb brightening. We won't get into the physics of limb brightening in today's daily space weather video. But there are the images of the sunspot groups and filaments. Again, sunspot 2816 over here is quite significant. And we'll be showing you diagrams. We'll be showing you imagery of Galileo's drawings later in the video. KP index, a measurement of global geomagnetism, currently at 3, the same as we reported yesterday. And we are expecting this to be back to geomagnetic storm levels first thing tomorrow. A G1 class geomagnetic storm expected tomorrow on April 17th. Next, checking out the real-time solar wind. And what we're looking for here is a major uptick in the density. So we only see a minor uptick in the density here, which coincides with a change in the temperature. That is typical of coronal hole wind stream arrivals. But this one looks like a sputtering, little weak signal here. We did see the levels reach all the way up to about 23.5 protons per cubic centimeter. Right around midnight, actually. Midnight universal time there. Current conditions are solar wind density 6.48 protons per cubic centimeter, solar wind speed 430 kilometers per second, so slightly elevated there. And we see the temperature actually having climbed in the last couple hours as well. Also the BT-BZ, which is the top plane. The BT is the total magnetic field, and the BZ is the polar orientation of the field. Current BT at 7, current BZ at +1. So we see a pretty equal amount reflected in that BZ figure of 1, both poles contributing fairly equally to the total field of 7. That's nanotesla. Next, looking at geospace magnetosphere movies. Here's 4 hours of data. And we're expecting a small uptick here in this movie. You should see the pressure rise a little bit as the movie continues. Again, it's 4 hours of data courtesy University of Michigan. And there you can see that small uptick in the pressure measured in nanopascals. Keep in mind, folks, this is a model based on the Space Weather Modeling Framework, and if you want to read about what that includes, click on the Details tab down here, and you'll find links to the Space Weather Modeling Framework. It includes many missions. Next, looking at perturbations on the ground. Ground magnetic perturbations, otherwise known as geospace delta B, changes in the Earth's B field, this one in nanotesla as well. And we see some perturbations over the Canadian North Pole, over the Siberian North Pole, over the South Pole, which is someplace down here south of Australia. Also 4 hours of data. You can see it calm down there at the end. Let's put that back to where it was. So it looks like conditions have calmed down in the past half an hour or so. Did you know about our Discord channel? Well, we've got a Discord channel. And if you head to smAsho you can find a permanent link to that. To join a Discord channel, folks, you need an invite, and we put a permanent invite link on our Discord channel for that purpose. We also regularly stream live to Twitch. Check that out if you like, twitch.tv/smAshomash. Thanks most of all to our YouTube viewers. Don't forget to check out our playlists as we put out other content besides the daily space weather. youtube.com/smAshomash/playlists. Thanks to our BitChute subscribers as well. And let's do a cosmology segment. And for today's cosmology segment, we will also stream live to Twitch. Welcome to our Twitch viewers to today's cosmology segment. It should be interesting, as we'll be, well, showing you various things here. So first of all, we're going to go over cosmic rays. Here is the cosmic ray situation at Apatity and Barentsburg over the past 30 days, which is this middle pane here. And you can see a downward trend over the past 30 days at the Apatity neutron monitor. Here's Barentsburg. Flat over the past 30 days at Barentsburg. Next, we'll go to Athens, Greece, which is much farther south. And there's the Athens neutron monitor. You can see a slight downward trend at Athens as well. Going even farther south to Mexico City. Small downtick at Mexico City over the past 30 days as well. Not a particular surprise here. And how about Oulu? So here's Oulu, Finland. Pretty flat over the past 30 days at Oulu. Let's check DOMB Antarctica. Small downtick at DOMB Antarctica. Here's DOMC Antarctica. Slight similar downtick at DOMC Antarctica as well. And that's the cosmic ray environment. Let's talk about a follow-up. So a couple days ago, we covered a story entitled Weird X-ray Surges Detected in Crab Pulsars Radio Bursts by NICER. Here's a follow-up to that. Mysterious giant radio pulses from pulsars are hundreds of times more energetic than previously believed. And this is a SciTechDaily.com article, so perhaps check that out, SciTechDaily.com. Interesting article here about the radio emissions of pulsars. This one in particular is about the Crab pulsar, which is believed to have created a nebula in about the year 1054, as detected by Japanese and Chinese astronomers. And there's a bit of the signal profile of that. Again, this article will be all over the Science Wire. That one is from SciTechDaily.com. Let's pick a random number. It's 259, which will coincide with something at the Neil Gorell Swift Bat X-ray Observatory. Let's see what it might be. And entry number 259 is Maxi J0758-456. Some sort of an X-ray source. It's only been monitored for about 5 years, as you can see here in the upper pane. It's a fairly consistent X-ray source. Here it is over the past 30 days. It's actually been weakening over the past 30 days there. And we can't show you this one on Simbad or Aladdin Light. So let's just pick another object here. And we're going to take a look at Cygnus X3, otherwise known as Deneb, the tail of the swan. And we just saw a massive X-ray burst from it. So there you go. And that's caused this graph to expand again. Is X3 going into an even louder X-ray state? If so, that's serious news, as Cygnus X3 is one of the more important objects in the Milky Way galaxy. It's the most intrinsically luminous object visible from our solar system. And we're trying to get people with radio telescopes to fix their gaze on this as it goes from an X-ray loud to X-ray quiet state. And you can see these transients here. Check this out, folks. These transients here, this is about 0.18 would be well off of this historic chart. 0.18 would be like up here somewhere. So some very high energy X-rays coming out of there of Cygnus X3. And we'll show you this on Simbad, the massive X-ray binary believed to be a Wolf-Rayet star orbited by an even more massive radio source at relativistic speeds, hundreds of kilometers per second. And here is X3 on the Chandra. So it's a very bright X-ray source. It's an object believed to be, I'll just call it a massive radio source, orbiting a massive Wolf-Rayet star, which is so huge that it would be about the size of Mars's orbit. If it were in our solar system, centered where the sun is, you'd be inside of it, actually. And it's more than interesting. Also, Göbekli Tepe is oriented toward Cygnus X3. And there's the massive companion object as viewed by pan-stars. Here it is on 2MASS, and you can see there's clearly two objects there. And this right here, folks, is a massive disk of ionized gas and dust in between the objects. And if you want to read more about Cygnus X3, head to smAshomash.com/forum in the Cosmology Forum. You can read all about it. Check it out. It's sunspots drawn by Galileo in June of 1612. Now, here at the Smash News Network, we're very interested in facts like this. And so here, Galileo started drawing sunspots in June of 1612. And here are some of the first sunspot drawings by Galileo. And what we're talking about here is an article about the attempted reconstruction of the sun's behavior based on those drawings. And we can take a guess in terms of what the sun was doing based on the size, shape, and location of those sunspots. As we know, sunspots near the equator happen closer to solar minimum. Sunspots migrate toward the equator, folks, at solar minimum. And anyway, if you want to read this one. By the way Galileo counted sunspots was not by looking through a telescope. He used a helioscope where the sunlight would be projected onto another screen inside, as you can see on this image here. It's a helioscope, and you can pretty easily build one of these yourself. I won't get into it, as that is today's cosmology segment. Thanks for tuning in, everybody. Thanks, Twitch. And I'm going to have to say goodbye to Twitch now. Bye, Twitch. As we continue on with the daily space weather. Patreon.com/smAshomash. And next thing we'll talk about is electron flux. Here's a one-year chart of the electron flux. Here's a 3-day chart of the electron flux. And we see very low levels, and we're expecting to continue to see very low levels for at least the next 36 to 48 hours, possibly even longer, depending on how long the coronal hole wind stream lasts. It's showing up early, and it might stay late. Here's the forecast model. The green boxes are the forecast. The yellow diamonds are the observation. No arguments from me there. And here's a diagram of the Earth's Van Allen belts. Keep in mind, folks, distances are in miles in this diagram. Pause the video if you must. Here's a visualization of the total electron content, and we're expecting to see very chaotic electron belts here to continue. Expect to see GPS errors even at nighttime around the equator. As you can see there, nighttime GPS errors happening before your very eyes. Here's another diagram of the atmosphere. This one is from a bit of a different perspective. It's showing you the penetration of electromagnetic radiation and how far it makes it. For example, X-rays are mostly adsorbed by the time they reach the mesosphere. Visible and infrared light make it all the way to the ground. And near UV is mostly adsorbed by the time it makes it to the troposphere. It also shows you temperature at solar minimum maximum, as well as the location of the Ionosphere layer over here at about 300 kilometers. Here is the ionosphere map, vibrational frequency in megahertz, otherwise known as millions of vibrations per second. And we see pretty anomalous ionospheric behavior here, no real surprise, especially considering the total electron content we just showed you. Each tick of the clock here represents 15 minutes. And it's looking a little anomalous here. You can see it's pretty charged up on the nighttime side, as well as some rapid charge ups and charge downs. Some rapid charge ups happening there over the northern Indian Ocean. And keep in mind, folks, the radiation output of things like oceans does affect the ionosphere. And also keep in mind the resolution of this map is only 1 megahertz. It's not going to help you forecast earthquakes. Anyway, here's the latest image coming through at 9:15 Universal Time. And you can see a very large blob of charged up region there and a very narrow band of F1 layer, which is this red spot there, the F1 layer, folks. The F2 ionosphere layer usually turns into an F layer at nighttime, and the location of the F layer is at a very small portion at this point. We've got hurricane force winds in the southwestern Pacific. Here are the surface winds. And before we continue on with the meteorology segment, let's welcome back Twitch. Welcome back, Twitch. Cheers, and thanks for tuning in. So here's our meteorology segment, and the first thing we're looking at is this hurricane force wind situation. 80-mile-per-hour winds here north of Papua New Guinea and east of the Philippines. Anyway, here are the jet streams, and you can see there is a signal actually in the jet stream level there, an indication this system may intensify, but I would suggest not, as we see a bit of a counterclockwise rotation there. Really strong hurricanes typically see a clockwise rotation in the jet stream level. This is the 250 hectopascal winds, by the way. Also some extreme meridional jet stream flow here in the northern hemisphere. You can see up here these north and south portions of the jet stream. Here are the jet streams of the Western world. Let me rotate that a little bit to get Europe, at least Western Europe. And we'll also show you surface winds. Here are surface winds. And some strong winds continuing in the North Atlantic here, as well as some odd ridges. You can see very calm conditions bordered by quite strong winds. Essentially low pressure ridges there. Low pressure troughs, I should say. Next, looking at pressure maps here on windy.com. Windy.com, they've got a great mobile app. Let's move this forward for the GFS forecast. Here's the GFS forecast for pressure at 12 noon Eastern Daylight Time tomorrow on April 17th. Lightningmaps.org is our next stop. I like to access lightningmaps.org when I hear thunder. And it looks like we may have some terrestrial lightning here once again in Louisiana. Hey, Baton Rouge, go out and look to your west. There's a pretty severe thunderstorm over there. Check it out. Look at all the strikes coming in, folks. Some significant lightning there. And here's the world map. That's pretty much the only location for lightning. Check out weather.gov. We see all kinds of crazy snowstorms happening, like in the central Rockies, actually, as well as, check it out, frost advisories here in Kentucky and Tennessee and North Carolina. Also some gale warnings there off the coast of Maine, New Hampshire, Connecticut, Cape Cod, Massachusetts, etc. Here's a U.S. Doppler radar map, folks. You can see heavy snow falling here in northwestern Kansas, the entire western half of Nebraska, the most of the eastern half of Colorado, also Montana, Utah, Idaho, Nevada, North Dakota, South Dakota, New York, some of Pennsylvania, Connecticut, Vermont, New Hampshire. There's still snow falling, folks. It's the 16th of April. Let's check the snow totals. And there is a lot of snow water equivalent here showing up. So we show this on the regs, folks. The snow water equivalent, it's interesting. It's outside the 1 standard deviation range. The blue line there is 1 standard deviation above the average from 1998 to 2011. Here's the snow extent tracker. So the snow extent is actually, in other words, the square mileage of snow cover for the northern hemisphere is actually right in the middle of the range right now. And the snow mass is actually within 1 standard deviation as well. Although you can see here at the top of the chart, it made it all the way to 2 standard deviations above normal at its peak, something we saw now for 4 winters in a row. 2017 to 2018, 2018 to 2019, 2019 to 2020, and 2020 to 2021 all saw 2 standard deviations above normal snowfall, at least at some point on the graph. Apparently, it's so hot that it's cold. Next, looking at the cloud layer. It's too dark to see it with the visible satellite, so we use the 3.9 nanometer radiation map, part of the NASA GOES Interactive Weather Satellite Suite. Bunch of low clouds here off the east coast. And here's a water vapor map. And we've got a rotating low pressure system here over western Lake Ontario. The low is right about here, folks. You can see based on the rotation of these clouds. That's about where your low is located. That counterclockwise rotation is a dead giveaway. And again, here's the Doppler. We'll close Global Cryosphere Watch. Doppler. Cloud layer. Water vapor. And that's today's meteorology segment. Thanks for tuning in, Twitch. We'll see you next time. And we've got bonus features for you here, folks. We're going to show you the colorized magnetogram as well as the solar intensitygram at high res. So let's go down the list. Sunspot 2814 has degraded. Sunspot 2815 has degraded. And Sunspot 2816 has not degraded. Those are quite large umbrae there, folks. Quite large umbrae. At least 3 well-defined umbrae. It looks like there's going to be penumbra associated with that as well. Again, here's Sunspot 2816. It's significant. And we'll close things out at 171 angstroms. Thanks for tuning in, everybody. Remember, stare at the sun. Attempt to understand the physics. Don't drive regardless of if you drink or not. Seriously, if you're drinking, don't drive. We'll be keeping an eye on this situation. Possibly look for another video coming from us today. Here's a close-up of the southern hemisphere. Great view along with the Earth scale here. Thanks once again for tuning in, folks. Remember to share the content on your social media. Click our links. Support our channel via patreon.com or perhaps our merch links. You can find all of that, all the links to all of our social media, etc. at smAsho.com. And may that solar wind be at your back.